Hello, friends, and welcome to Career Talk. Friends, if you are looking for practical advice and plenty of examples about matrices, then this session is perfect for you. Today, I am delighted to have Parshuram joining us. He has conducted several sessions with us in the past, with the most popular among them being the top 10 agile matrices, which we published in 2022. Friends, believe me, to this date, I receive requests for the free template associated with that session. So, if you haven't had the chance to see it, I highly suggest watching that session as well. The link to that session is provided here or here somewhere. I don't know. And you can also explore our matrices playlist, which contain numerous videos on this topic of matrices. So now today, Parshu is presenting another interesting topic, flow matrices and Dora matrices. I am sure that many of you may not even heard about these two terms before. So it's important to watch the entire session and please do not skip the beginning. Otherwise, you may not fully understand the context and will not understand the template part. So friends, before we start, if you are new to our channel, please consider subscribing as you will discover a valuable information regarding Agile Scrum. Also, don't forget to smash that like button. Your support means a lot to us. So with this, welcome Parshuram and thank you for giving your time today. Parshu, over to you.
Wonderful. Thank you very much, Sunand. It gives an immense pleasure to come back to Career Talk. After, we just were having a discussion, before starting the recording. It has been more than a year since we both spoke, and we are speaking to the Career Talk, subscribers. As you rightly pointed out, that Agile metric session was kind of a turning point, I would say. Even today, people, ping and, check out how can I support them in terms of metrics. So that is thanks to you. Thanks for the community, Career Stock community, and all the subscribers and viewers who watch and share their love, by watching the videos and sharing the videos to all they love, right? Wonderful. So yeah, today, even last metric session, I would have given a glimpse about what flow metrics is. However, uh, over the past 1 year, where we had spent a lot of time on flow metrics and Dora metrics in multiple projects. Even before that, as well, there were multiple tools that we have explored for flow and flow metrics, especially not really Dora metrics, but I wanted to share my learnings back to the community, so that the first motto is sharing my learnings, and at the same time, if my learning has any gaps, I wanted to learn back from the community if I had mislearned something, so that I can unlearn and relearn. All right. So with that, I'm gonna go ahead and share my screen. Sunand, I need your confirmation as soon
Yeah,
as you
please,
see the
please.
screen. Yeah.
Yeah, please go ahead. And by the time you share your screen, so friends, this Dora matrix is really picking up. Recently, I've working with one of the USA client, and this DevOps thing, of course, is everywhere nowadays. So this Dora matrix, you must, I would say, know about nowadays. It's just picking up, so it's good. Like it's coming up on our channel recently. I've not seen many videos on that Dora matrices lately. So yeah, definitely that's going to help us. Yeah, Parshu, I think you are sharing
Wonderful.
a screen. I can see matrices 2.0. Yeah.
Excellent. So yeah, Sunand.
Okay, so this one, that video, that session which we are talking about. So this is that session. So if you've not seen that, now we have just put it this image. So you can go and watch it later on once this session is over. So you will get the complete end-to-end picture. Yeah, Parshu, please go ahead. Thank you.
Thank you. All right. So, before we get into and start about flow and Dora metrics, I want to take a step back and help you understand or take you through the context behind it. Why do we really need this metrics? What are the challenges that we have with the current metrics that these metrics could help us overcome? See, the very first thing is, once we came into agile way of working, everybody started using metrics like velocity, metrics comparing the predictability by actual uh, actual or planned story points versus completed story points and all that. So these are all, yes, supporting at a team level to an extent. However, to improve the business or get the business agility part of it, where, what is the time it is taking for one feature from start to end? How much time are we really taking? Right? None of that was being measured in our traditional agile metrics that we were actually looking at. And then, so when we actually identify this, what we eventually gonna get is to understand what are the bottlenecks within this whole system, so that we go ahead and address this. So in the current context, if you see in Save 6.0 also, there is an enormous importance is being given for flow. Why? So keeping that flow in mind, we will be able to predict actually when these items are going to come out. Forget about velocity, forget about actual or your predictability of getting this. How about coming up with a predictability using the time, right? So in this, we will try to learn what are the different metrics that are going to help to understand what is time to market is and how each of these metrics influence in improving our time to market. So when the time to market is decreased, that is improved, your value delivery is eventually increases. So I'll give you a good or an example before I move ahead, right? We all take Amazon, right? If you go back, say about 5 years, 6 years behind, any Amazon delivery used to take about 5 days, or initially it was used to be 2 days, 3 days. However, currently we have same day delivery in certain cases, same, within couple of hours. How are they able to do it? Simple trick is they try to identify from start, from the order placed time till the order is delivered, that is value is delivered to the customer, what is the time taken and what are all the bottlenecks in the system, and come back and optimize each bottlenecks. That is why currently even a non-prime member is able to get a delivery within a day or two. Same goes to our software context, right? Have you ever thought about, okay, a feature is being requested by our customer, how much time is it really taking to complete that, right? In a recent example, right, in a very, very recent project where we have delivered about 30 different features within the matter of about 3 to 8 months. Sorry, 3 to 4 months, right? If I just take a look back, those features, 50% of the features were there in the system for more than a year, right? So nobody was actually looking at it. So now we still have to understand what exactly is the load. What are all the aging features that are still existing and still customer is waiting for it. So we are actually bringing it, optimizing our value flow process and completing it, right? As I always say, metrics is a starting point, right? It is not the end. Metrics is a starting point where you will try to understand what exactly is happening today so that I can improve or optimize further tomorrow. With that context, today we are going to talk about very, very simple two metrics: flow metrics, Dora metrics. In each of these metrics, I'm going to help you understand about four parameters or four matrices in each of this. In flow, you will learn about flow velocity, flow time, flow distribution, and flow load. And then in Dora metrics, you will learn about time to change, MTTR, right? All right. Let us go ahead and learn about flow metrics. The first one, flow velocity. It is more of a productivity metric to measure how many items are being delivered over a period of time. So if I take a step back and look at it, it could be also called in a traditional term as the throughput, right? For a period of 10 days or say 1 month, how many items have we delivered, right? That is flow velocity. Again, going back to the, let's say, software context example, what I was telling, we were able to deliver in a 3 to 4 months time, we deliver about 30 features, 30 work orders. Actually, when we took a step back, we were able to plot a very good diagram in every month, how much I'll be able to deliver, which identifies a pattern. In Jan, the team delivers 5 items. In February, they delivered 6 items. In March, they delivered only 4. And then it is in April, they delivered about 7. So this helps in identifying how a team is performing month by month. When it is low, we can go back and retrospect about why they have delivered less. When they have delivered more, it is not only celebrating, but at least go ahead and see what is the best practice that we have done so that they'll be able to deliver. When I take a 6 months view, if the pattern is up and down and up and down, we could clearly plot, okay, what is the reason there is a down after every peak, right? So that is where this flow velocity or productivity is going to help. Example is pretty straightforward and simple. Your team A has delivered 5 features in a month. Team B is delivering 3 features per month in the last 1 year. All of this is flow velocity. Next up is flow time. So this is what I was talking about. This captures the time of a flow item. Flow item meaning here consider you have a feature from start when that feature came into your system till it is delivered to the customer, right? That is what is my flow time is, right? In a traditional term, this is also called as cycle time, where you understand when a customer request came in and how much time did it really take to complete that. The difference between the end time minus the start time is your flow time, right? In this, you would measure both active and wait time, right? There is the active time is nothing but how much time I'm actually doing the work, and wait time is how much time I am not active. It is staying without any action. It is waiting for an action to be taken, right? So that is what is flow time is. Example, you have, say, a team takes average of 6 days to complete a feature, whereas team B takes an average of 3 days to complete a feature, right? Or a defect. So that means any feature that is going to come into the system, on an average, it is going to complete in 6 days. Certainly, there could be certain outliers, like certain features would have taken 10 days, certain features would have taken 3 days or 4 days. However, on an average, it is only going to take 6 days to complete a feature. So that means it clearly gives a predictability on a particular team. Say, any feature that is going to go in, that team is going to complete it by 6 days. That is what is flow time. Then flow distribution, right? Over a period of a week or month, what is the distribution of work where the team is really focusing on, right? We saw, we all know, right? Like this team has completed 5 items. Okay, but out of 5 items, how much were value deliverables, that is features, or how much is defect, how much is tech debt, and how much is risk, right? Unless you understand that, you will not be able to say the team is really delivering value, or they are working on some tech debt or defects from the for the previous value that was delivered, right? So that is where flow distribution is going to help the teams. It is clearly to understand, if I am working on multiple items in a particular week or a month, what are the different types of work items that the team is working on? That is going to help in terms of, if the value delivery is less, that means the revenue generation for that particular team is less, then we could focus more on value delivery. If the team is not focusing on the defects, there are a lot of defects that are there in your backlog, then you could increase the time, or you can increase the proportion of defects that team could work upon, so that they clear off the backlog of defects. So again, this would give a very, very good leading indicator to understand how in the next month, how based on the backlog, the team has to work in the future. And then finally, flow load, right? This is very, very important, where the number of items are committed and work in progress, right? I said, I have a commitment. Okay, this has come to my backlog. Yeah, I'm going to take this up. I'm giving a very simple example, right? This particular item has been pushed or pulled by team A. That means I'm committed to it. And then I have n number of items that are being work in progress. So that means the items which are committed and in to do, plus the items that are currently in work in progress, the combination of both of this is called flow load, right? Why this flow load is really important, which will determine how long the team has worked based on the flow time they have. For example, there are 200 items in the work in progress, that is your load. Whereas the current flow time that you have identified is, on an average, it's going to take 2 days per item. So on a rough estimate, it is like for 400 days worth work is already committed and stays in this particular team's bucket. That is what is your flow load is. The metric refers to number of items that you have committed and are currently work in progress. I'll take a pause here. Sunand, do you have any questions before I move ahead to Dora metrics?
No, I think we are good for a time. Yeah.
All right. Uh, yeah. Now, before I go ahead and talk about Dora metrics, I would like to quickly demonstrate, how this flow metrics I have calculated using a simple Excel sheet. Let me share my screen.
Okay, so by the time you are sharing your screen per show, so friends, if
Yes.
you require the matrix Excel sheet template, which we have used in this session, there is no need to email me personally. Simply share this session on your LinkedIn wall and tag career stock, and I will send the Excel sheet template via LinkedIn. So this serve two purpose. You will receive the Excel template quickly, promptly, and of course, you will also help promote our or your own go-to channel career stock. So don't forget to check the spelling. It's S in between. Sometimes people spell it wrong. So that's the thing. Yeah, Parshu, please go ahead.
All right. Yes. Uh, everyone. So I have a dump of, different data. So again, it is a Jira data, but in the interest of, projects and teams, I had to, cleanse this with Jira
Mhm.
IDs as Jira and teams as team A, team B, team C. So now I have this particular dump where in this dump from Jira, I have taken created date, resolve date, due date, review start, review end, dev start, dev end, test starts, test end, deployment start, deployment end. All of these dates are directly available in the in
Jira board.
Jira.
Yeah.
Yes, in Jira board. But in certain cases, it is configured. In certain cases, based on the status change, you have to manually pick it up. Right? So I'm repeating it. In certain cases, it is clearly available as a date field. Whereas in certain cases, you have to pick that time or date change using the status change. Okay. So now let us quickly go and see how I have calculated float velocity first. So if you look at this, right? So this particular team, I have plotted team A and team B, right? For team A, in Jan month, they have completed about 16 items, whereas team D had completed only 2. Like that, over the months, so this is how the trend of both team A and team D have completed. So here, this is a very, very simple calculation based on the resolved date of this particular tickets. Here I am considering only resolved date. Resolved date is the in Jira. Whenever you mark something done, it'll automatically populate the resolved date. That is how my Jira board is configured. So based on the date, and I have taken the month from that particular date, and this is how the flow velocity of team A and team B is. Right, where they are able to deliver X number of items over the period of time. Right. Here we are not trying to compare team A or team D who is best, because we are not talking about their technical capabilities. They are not talking about their team size, but we are taking a step back and just trying to understand how do I calculate two teams, flow velocity. In fact, in this, I have for 4 different teams. When that is plotted, it looks like this, right? Where team A is marked in blue color, team B is in orange, team C is in gray, and team D is in yellow, right? As I said earlier, this particular metric is going to support in identifying a pattern over the past quarter or a half year or a month or a year, right? How much is the team able to complete, and what is the pattern of completion? Is there any abnormality within this team? Right? This is what flow velocity is. Let us go and quickly try to understand what is flow time. Here, the flow time. Flow time, as I said clearly, in this sheet, I have, okay, I think these are all I have calculated and copied this. It is a simple subtraction between my resolved date and the created date. So these two, right? That gives my complete cycle time, whereas my flow time is where I take when this particular item is committed for this particular team, and then when they have resolved it. So over the period of time, so if you see for, I'll consider for team in the month of Jan, all the tickets that were completed in the month of Jan, the team took about 15.9 days to complete a ticket. For the tickets that were completed in February, they took their average flow time is 11. Whereas when they have done it in March, it is 20.3, and it is slowly, increasing and decreasing based on the tickets in that particular month. So this could be pivoted in such a way where what is the average flow time for a team level also. Here I have shown a graph month wise. So this could be done on an average for all months. How much is this? For team A, the average time taken or average the flow time is 17.7 days to complete one ticket. Right? And then now we'll go into the most interesting one, flow distribution. So you've seen the velocity of each of these teams, right? So let us quickly try to identify just for team A, what is the flow distribution is. Right? In velocity for team A, we have seen, let me take one, quickly filter this just for team A. Right. So this is how my team A is currently doing. So they have totally completed 16 items in January month. However, look at this. They are focused on 3 items on tech debt, 7 items on stories, and type risk. They have completed 4 items, and of the type bug, they have completed again 4 items. This is their distribution. Again in August, which is the maximum they have done, which is where they have spent 40 or completed 40 number of stories. Risk is 10, bug is 14, tech debt is 6. So here again, there is no comparison between, two teams or multiple teams. It is over the period of time, how much of efforts are going on. If you see the pattern, this team is heavily focusing on story delivery only. Yes, there are certain outliers, especially in the month of August, June, and September. The team has proportionally high time or high number of tickets they have focused on the tech debt area. But barring that, this team has predominantly spent their efforts in completing user stories. That is what is the inception that we get. right? So this is about flow time, flow distribution, and flow velocity. So I have this formatted sheet that you would, if needed, you could use it. And if I go much deeper into this, right, I have certain times that I have brought in here where something called cycle time, which is the actual created date versus the resolved date. I also managed to pull in what is wait time. And if we wanted to, in one of my engagements, where I have given times for each of this, where how much we are spending in development time only, that is dev end minus dev start. How much are we spending only in testing, test start minus dev end? The wait time between dev complete and test start minus dev end, right? How much time are we spending in review? It is review end minus review start, right? So all of this is a possibility to go and identify what is the bottleneck within your system, right? With that, any questions before I move ahead?
See, I can only see, Parshu, that whoever is watching this session, right, I
Hmm.
highly suggest them to go back and understand the basics again, because I'm
Yes.
sure that most of the people, despite I told them to watch the session from beginning, they missed lot of things. See, guys, you will get this template, but if you will not able to understand it, how you will explain this to your team members, to other people, right? So it's very important to understand, first of all, the basic, the foundation, that okay, what's the use of these matrices, why we need lead time of all this flow time and all these things, and then you jump to this template. The most of the time I see people do this mistake, they just directly jump to the template or the matrices, and they don't understand like why we are using it. So how part is easy, but then why part somehow people missed it. So that's the only thing I just want to suggest over here for sure.
Wonderful. Wonderful. All right.
And one last thing, friends, all these templates which you are, right now saying, it require a lot of time and effort. Okay, you can just see like this, but if you want to build yourself, I'm not sure how much time it will take. Okay, so please respect the time which Parshu has spent on this, and the only way you will get it is share on the LinkedIn this particular session, and then only please ask to, please do not send us one-to-one message to me or to Parshu, right? We are not able to reply back to you. Yeah, of course, if you have any doubt on the matrices part, of course you can reach out to us, but without sharing on LinkedIn, if you're just asking us for this template, unfortunately we are not able to give you guys. Yeah,
Absolutely.
we have to make this hard stop for sure. Yeah.
Yeah. Fair enough. Shall we move
Okay.
forward?
Yeah, please go ahead.
Yeah. All right. Now, let me quickly showcase what is Dora Metrics is all about.
I can see your Canva. Yeah.
Yep. Wonderful. See, Dora Metrics. Now, we try to understand the business concept of it. What is the productivity, how much time it is taking to completion, what are the different times that are, different type of work items that are being completed, what is the load or work items that are sitting in my bucket. Now, going to Dora Metrics. See, Dora Metrics is suggested by DevOps research assessment, which talks about again 4 types of metrics, in which the first type is deployment frequency, right? Refers to the frequency of successful software deployments or releases to production, right? So now, how frequently are going to production, right? In fact, I have to correct this. It is not software releases, it is software deployments, right? how frequently I have to, I'm deploying my code into production environment. So what it shows is like how fast, I can get any change to the customer, right? How many times am I going? So this actually also implies what is my stability of the processes in doing the change management. Okay. So in my example, I have, multiple types of production deployments where I have a weekly deployments, right? And then we have something called monthly, we have something called quarterly. So these are the different types of software deployments. And then based on the need for the customer, these would be released. Okay. I'm sure you understand the difference between deployment and release. However, deployments are very frequent and continuous. However, my releases are, based on the demand from the customer. Keeping that topic aside, when we are focusing on this deployment frequency, this only talks about how frequently, the software is being deployed to the production environment. That is what deployment frequency is. And then lead times for changes. So this is a very tricky metric where I've been having a debate with multiple people. So I want to open this forum also to correct my understanding on this, where my understanding is this. This actually captures the time between a code change commit and its deployable state. That means once I completed my development and I've committed the code, and from there, how much time does it really take to go into deployment, right? So this is gonna, in my understanding, how much time does it take for your change management process? It could be integration testing, it could be regression testing, it could be UAT, and it is there in the production deployment. So what is the time that it takes, right? So that is what this lead time for change talks about. However, there is a different understanding for this, where people sometimes say, hey, this is also equivalent to something called flow time, where from the start of my development till my completion of that development, right? We are not talking about cycle time where it is from the created to the end date, where in certain examples, what I use, I consider, I don't want to confuse you with the different times. I always say from the created time to the end date. Consider there is a big gap between created time and the time I actually commit for development or take into the development, right? So these two, right? So now people also say from the time I start my development till it goes and gets deployed, it's also called lead time to change, right? But for this context, I would still believe it is like after I commit my code change till it goes to the deployment. That is my lead time to change. That would help you understand how are my processes being there between my code commit to deployment, and what is the optimization that is required. And then mean time to recovery. This is the time that measures between an interruption due to deployment or a system failure to full recovery. All right. For example, there is a catastrophic failure after your deployment, or in a running system, there is a catastrophic failure. That is, there is a P0 or P1. How much time do you really take to restore the system back is mean time to recovery. And in my previous experience, I also learned mean time to recovery is just not limited to P0s. We can measure for all, that is P0, P1, P2, P3, to understand what is the mean time to recovery for each of these priority bucks. That is P1, P2, P3, P4, and P0. Right? It is to understand how much time does it really take from a failure to full recovery. And then my favorite and most important, what is the change failure rate? Indicates how often a team's changes or hotfixes lead to failure after the code has been deployed. That means, so once your code is deployed into your production environment, immediately that goes for a rollback, or it needs a hotfix on top of it to immediately resolve it. Right? How many times you have got a P0 as soon as you have deployed something? So that means your change, which you have pushed recently to production, has failed. Right? In one of my cases, when we were looking at this, there is a program where my change failure rate is 0. There are no new catastrophic errors. It has been for the past 10 to 15 releases over the past 2-3 years. There is no change failure rate. Whereas in another experience where my 2 out of 5 deployments result in a failure. So very, very interesting thing, right? There was this was a discussion between my chief product officer and myself in my previous engagement, where that person used to directly blame or comment on the team, saying every time this change is pushed to production, there is some or the other error. Users are not feeling happy. All right. We quickly did a root cause analysis of, okay, what is the change failure rate for the team? How many releases have we done over the past 5 to 6 months? And how many bugs have we got from production because of the changes that were pushed? Very interesting point is there were only 2 bugs, that too in the period of first one maybe in Jan, the second one is in May, and that too on a boundary value condition. However, the picture painted earlier was anything and everything that a team deploys, leads to a catastrophic error. Users are not pretty happy with it. No, this kind of a metrics is going to support you with how qualitative deployments are we sending to the customer, or how qualitative changes are we deploying to the customers. With that note, I'm going to quickly share with you about the 2 metrics that are covered as part of examples, that is lead time to change and mean time to recover. Quickly, lead time to change, as I said, it is dev end to deployment end. Lead time to change is dev end to deployment end. So
you're sharing some Excel sheet, or where are you? I can see on your Canva.
Oh, is it? Let me reshare it.
Yeah.
Now are you able to see this?
Now I can see. Yeah.
Yeah. So the lead time to change is measured like this, where your R, lead time to change, is nothing but deployment end date minus your development end date is the lead time to change. However, in your context, you could quickly wrap it up saying lead time to change is dev end date minus your dev start date as well. However, in my understanding, I am not considering the time taken for development as part of lead time to change. I'm just focusing on test and deployment times. Okay. Yeah. See, these are all given in this for Excel just for format purpose. If you have multiple phases of your testing, you could have all those as columns. Right? If you have a different review, this review here is not code review. There is a review and analysis process in our system. That is what I have put as review start and review end. Right? This is before the dev start. It is user story review or a feature review start and feature review end date. Okay. Quickly going on to mean time to recovery. So as I said, it is again average time taken for a bug to resolve. Right? Yeah. This is my time to resolve. So I quickly go ahead and see where is time to resolve in this sheet. These are open bugs. This is my resolved bugs. So time to resolve. So time to resolve is calculated as G2 minus H2, which is nothing but created resolve date minus created date will give me my time to resolve. In this, I have identified for all the type of bugs that I receive from production, what is the average time it takes for completion. With that note, I come to the end of this presentation. Over to you, Sunan.
Great, Parshu. Parshu, can you just click on the link which I just shared, the first one?
Yes.
Okay, and you can share your screen. So, friends, of course, you can take help of Excel, but I think Jira also now realize the value of these DORA matrices, and they're also introducing all this thing into the Jira. So these are just few links. You have to, of course, spend
Yes.
some time to understand this. But yeah, so it's possible in Jira, but then you have to spend some time into it, like how to configure that. I think there is some Compass, if I remember correctly, is also there, and I think DevOps in Atlassian Analytics is also there. I think DevOps data tables, how to configure in Atlassian Data Lake, things are also there. So there are a lot of topics to explore.
Yes.
Jira is not that simple, just which normally people use. It's very vast. Of course, we don't use many of their features for sure, but of course, if you are more interested, you can always go out and explore more that how you can do that with various tools. Uh, yeah, I think that's it from my
In
side.
fact, when
Yeah,
you said Jira, right, the current Jira AI, you need not write JQL, right?
yeah.
You just give a command, prompt. It is gonna create a JQL for by itself and gives the results.
Correct. I think last year only they roll out this feature, DevOps data in Atlassian Analytics, I think 2023, if I remember correctly. So it's pretty new. Not many people are aware about that. So that's the thing. Okay. Wonderful.
Perfect.
And I think, you have explained in detail, I think. So someone who really want to start, at least they can, of course, watch
Yeah.
this session couple of times. So thank you, Parshu, for that. And thank you,
Thank you, Sunan.
everyone, for joining us for today's session. And we hope that you found it helpful, informative. And if you enjoy the session, please don't forget to like, subscribe to our channel. And we
Yeah.
hope to see you in our next session. So, with this, thank you, Parshu, one more time.
Thank you, Sunan. One last note from my side
Yeah,
is, see,
please.
this is all my understanding and how I use this, right? But when what I encourage you also do is use it in your context and take the benefit of what is the end-to-end time and what are all the bottlenecks. That is what is going to help, and this is just a mirror, not the end point. This is just a starting point.
Absolutely.
Wonderful.
Thank you,
Thank you,
Parshu.
Sunan, for having me, and thank you,
Thank you.
viewers. Bye.